Very good morning, students. Today we can continue the topic of physics, that is the gravitation. Okay. So now here in that case we want to solve some numericals on the gravitation. So write down the numerical which has been given to here. Find the escape velocity of a body. Find the escape velocity of a body from the surface of Earth. From the surface of Earth. From the surface of Earth. If mean density of Earth is 5.52 gram per centimeter cube, R and G are given to you, means R is 6400 kilometers, that is the radius of Earth, and gravitational constant is 6.67 into 10 raised to minus 11 Newton meter square per kg square. Okay, so you want to find out the escape velocity. So you have the relation of the escape velocity with the r, rho and g. And what is that relation? 2 times r into square root of 2g rho into pi by 3. So I will substitute the value. V is equal to 2 times 6400 into 10 raised to 3 into under root of 2 into 6.67 into 10 raised to minus 11 into 5.52 into 10 raised to 3 into, that is the 3.14. Okay, so that will be the value and divided by 3. So now after solving these things you will get the answer. Escape velocity of that satellite will be 11.2 into 10 raised to 3 meter per second, or that is also given by the formula, that this can be calculated 60 or written as 11.2 kilometer per second. Okay, so now I will give another sum to you. If the critical velocity of satellite is 7.920 kilometer per second, okay, so what will be the escape velocity of the satellite? So you have learned the relation between the escape velocity and critical velocity. So escape velocity is square root of 2 times the critical velocity. Okay, so therefore VE is equal to, escape velocity is equal to root 2 1.414 into 7.920 kilometer per second, and if you will calculate that answer, you will get 11.19 kilometer per second. 11.19 kilometer per second means approximately again 11.2 kilometer per second. Okay, so that will be the escape velocity. So now again write down the another problem. Okay, compare the escape velocity from the surface of Earth. Compare the escape velocity from the surface of Earth and from the surface of Moon. From the surface of Earth and from the surface of Moon. Okay, can I rub this bachche log? Okay, compare the escape velocity from the surface of, okay, compare the escape velocity from the surface of Earth and from the surface of Moon. Okay, given that mass of the moon is 1 by 80 times mass of the Earth. Mass of the moon is 1 by 80 times mass of the Earth. Okay, and the radius of the moon is 1 by 4 times the radius of the moon is 1 by 4 times the radius of Earth. And what you want to find out? You have to do the comparison of escape velocity on the Earth to escape velocity on the moon. So what is that relation of r and m? Okay, so escape velocity is 2 times gm by r. So therefore, so it will be ve, g is constant, ve is directly proportional to square root of m by r. So therefore that will be m on earth to m on moon to the radius on moon to the radius on earth. Okay, so that is the relation. So now, can you tell me what will be the m e upon m? So m e, mass on earth, to mass on moon is 80. So that will be 80 into Rm by Re, that will be 1 by 4. Rm by Re, that is 1 by 4. So 4 ones are 4, 4 twos are 8, root 20. And what is root 20? 4 fives are 2 root 5. Okay, so what will be the relation? 2 root 5. Okay, 2 times root 5, mass of this. Okay, so that answer he has given, 2 root 5 is 4.47. 4.47. Okay, is to 1. काय रे मुलांनो, root of 4 5 is 2 2s are 4, 2 2 म्हणजे 2 point something into 2 means 4.47. It is the right answer. Okay, so that will be the next point. Again write down the next question. Okay, we can calculate the escape velocity. Find the escape velocity of a body from the surface of earth. Okay, that was the third problem. Now we can proceed for the fourth problem. Okay, so I'll write down. So you write down. Calculate the escape velocity of a body from the surface of earth where r is 6400 kilometer and g is 9.8 meter per second square. And what is the escape velocity? But escape velocity is equal to 2 times g into r. 2 into 9.8 into 6400 into 10 raised to 3 meter per second. And after solving this answer, you will get the answer as 11.2 into 10 raised to 11.2 into 10 raised to 3 meter per second, or 11.2 kilometer per second. 11.2 kilometer per second. Okay, so that will be your right answer. Okay, so this is how you are able to find out the different problems, that solution. Now bachalo, so we want to find out the distinguish point between the your critical velocity and escape velocity. So that will be the last point. So I will find out, that means I will tell to you, and then after that we'll stop here. Okay, so the next point and the last point is distinguish between okay, between okay, कोणामधलं डिस्टिंग्विश घ्यायचं मुलांना आपल्याला? डिस्टिंग्विश, GUISH, distinguish between critical velocity and escape velocity. Critical velocity and escape velocity. वेलॉसिटी. मुलांना आता डिस्ट्रीब्युशन मध्ये पहिल्यांदा क्रिटिकल वेलॉसिटीला डिफाइन करू आपण. ओके, याला पण डिफाइन करू आणि याला पण डिफाइन करू. काय डिफाइन करणार आहे? इट इज द मिनिमम हॉरिझॉन्टल वेलॉसिटी has been given to that satellite or provided to that satellite so that it will be that means remains in a stable orbit around the earth's surface. Okay, or it will revolve around the stable orbit. And escape velocity is the minimum velocity with which the satellite should be projected so that it will escape the earth's gravitational, that is field. So that is the escape velocity. Second point, critical velocity VE or VC is given by the formula under root of 2 times gm by r, critical velocity, and escape velocity is given by the formula 2 times gm by r. So third formula, we want to find out critical velocity in terms of acceleration due to gravity, so that is g into r. And here that escape velocity is given by the formula 2 times g into r. In terms of the mass, we have calculated critical velocity is equal to square root of 2r pi g rho by 3. And here critical velocity is equal to 2 times r under root of 2 times pi g rho by 3. Okay, so these are the distinguished point between that is your critical velocity and this your escape velocity. 2 pi g rho by 3 pi g rho by 3 gm by r 2 times gm by r. Okay, moreover you learn critical velocity is equal to critical velocity. Actually, we have learned this formula. Escape velocity is root 2 times critical velocity, or critical velocity is equal to 1 by root 2 times escape velocity. Okay, so these are the your distinguished point between critical velocity and escape velocity. There are some similar points are also there between the your critical velocity and escape velocity. Which are that similar points? Okay, so now you see here, first of all, similar points. Okay, so which are that? Escape velocity, critical velocity and escape velocity. Both they depends upon, okay, critical velocity depends upon mass and radius of the planet. Here also escape velocity depends upon mass and radius of the planet. Okay, it does not depends upon mass of the satellite. Here also it does not depends upon mass of the satellite. वर तो डिपेंड्स करताना दिसत नाही. त्याच्यानंतर मुलांनो critical velocity VC, okay, is directly proportional to R when rho is constant. Critical velocity is directly proportional to rho when the density remains constant. Here also escape velocity is directly proportional to R when rho is constant. Similar point. Last, critical velocity is directly proportional to square root of density when R is constant. आणि इथे सुद्धा मुलांनो VC is directly proportional to square root of rho when R is constant. Okay, so these are the distinguished point between the critical velocity and the escape velocity. Okay, so now what we'll do, I will take last one sum and then we'll stop with that topic. Okay, so can you write down one sum bachche log? That is the just last one sum. Okay, so we can find out what is the value of, okay, so that which example you want to find out the critical velocity and these. Okay, so where is that problem? So just minute now, chalo. So you have to find out. Okay, okay, एक मिनट है बच्चों. So you write down the problem. चला आपण एक शेवटचा एक सम घ्या. चला write down. The escape velocity from the surface of Earth is 11.2 kilometer per second. Escape velocity. I will write down last one sum. Escape velocity. Okay. Escape velocity VE is 11.2 kilometer per second. Okay. Mass of a planet is 0.107 times mass of the Earth. Mass of Mars is 0.107 times mass of the Earth. Okay, mass of the Earth. And radius of Mars is 0.53 times the radius of the Earth. Find the escape velocity of a body from the surface of Mars. Escape velocity from the surface of Mars. So chalo, we have calculated escape velocity of Mars to the escape velocity of the Earth is equal to, so that what will be the formula? V escape velocity is directly proportional to m by r. So that will be the mass upon mass of Earth into radius of Earth upon radius of Mars. मुलांनो mass of the mass किती होतं? m upon me 0.107 and re upon rm is 1 upon 0.53. Okay, आणि इकडे तुमचा होता मुलांनो हा escape velocity of mass Earth ची होती 11.2 किलोमीटर पर सेकंड. ओके, आता याला एवढं कॅल्क्युलेट करून टाका मुलांनो. 53 5 2 चा म्हणजे हा जवळजवळ 2 जा जातो बघा. त्याचा 2 जा म्हणजे स्क्वेअर रूट ऑफ 2 into 11.2 म्हणजे उत्तर येईल मुलांनो तुमचं 5.032 into 10⁻³ so therefore VEM is equal to 11.2 into 1.07 upon 0.53 and the answer is 5.032 into 10⁻³ meter per second or 5.03 kilometer per second. That is the velocity of mass. Okay, so that will be the your last sum. Okay, so chalo, so this is way how you have to, that means you have finished that topic gravitation. So your all the best for your exam. Okay, do well now. Okay, today we'll stop.